Okay guys, I welcome you to the channel which is about mathematical engineering, core theory and its applications, and I'm going to discuss some of the continuation of the concepts already been discussed in terms of integration, in terms of differentiation. And as I told you in the last video, I'm going to discuss some of the concepts which is about integration, and in the same time I'm going to solve some of the problems as well. So let's see what we have. First is integration in plane polar coordinates. Okay, so that is in plane polar coordinates, rho phi, a curve is defined by its distance rho from the origin O as a function of angle phi between the line joining a point on the curve to the origin and x-axis. That is to say, rho is equal to rho into phi. The area of an element is given by x and y this is b, this is c, this is rho d of phi. You can have this area as in d of a, this is p of phi or rho of phi, sorry, this is b, this is o, and this is c. This is rho into phi plus d of phi. So finding area of a sector OBC, which is O, B and C. This is a sector defined by curve rho of phi and the radii OB, OC, and at angles to x-axis phi 1, phi 2 respectively. dA is of rho square of d of phi as illustrated in above figure, and hence the total area between two angles, phi 1 and phi 2 is given by area is equal to phi 1 into phi 2 half rho square into d of phi. Area is equal to 0 to 2 pi half a square d of phi, which is equal to half a square 2 pi by 0, which would be equal to like this, which would be equal to pi a of square. That is the area. So that's how you're going to conclude this integration in plane polar coordinates. Okay, now wanna actually provide some of the integral inequalities. Let us discuss about that. That is a to b x into dx less than a to b f of x dx less than and equal to a to b phi of x into dx. So show that value of integral, which is this 0 to 1 plus x square x cube half into dx lies between 0.810 and 0.882. So solution or answer: x in range 0 less than x is less than 1, 0 less than x cube less than x square, 1 plus x square into 1 over half less than 1 plus x square plus x cube 1 over square or 1 over half 2x square is equal to half. You can have 1 plus x square, that is 1 plus x square plus x cube 1 plus 2x square half. Consequently 0 to 1 1 plus x square into dx, 0 to 1 1 plus x square plus x cube 1 over 2, which is greater than and equal to 0 to 1 1 plus 2x square half into d of x. So that would be meaning and logarithm x plus 1 plus x square, and that would be 0 to 1 integral. This one is the integral, which is normally given by this, greater than and equal to half 2 under root ln of x plus half x of square 0 to 1, and then it is 0.8814 greater than or equal to integral 0.8105 and 0.882 greater than or equal to integral greater than 0.8105. So this is how you're going to show it, which normally lies in this range. This is how you're going to, here's the solution. Okay, so now we're going to talk about some of its applications. Let's see what we have for applications of integration. Find number one is mean value m. Okay, so problem is find the mean value of function f of x is equal to x square between the limits x is equal to 2 and x is equal to 4. So m is equal to 1 over b minus a into b f of x into d of x. M is equal to 1 over 4 minus 2, that is 4, and this is 2, that is 2 to 4, and that is x square into d of x, that is half x cubed by 3, that is 4 to 2, and then you have half 4 cubed by 3 minus 2 cube by 3, that would be 28 by 3. Okay, this is how you're going to find it, the mean value. Now you're going to say what find now the length of the curve. So from x is equal to 0 to x is equal to 2, s is equal to a into b 1 plus dy by dx square into d of x. Y is equal to x cube by 2 from x is equal to 0 to x is equal to 2, and a to b is this one, and we're going to actually resolve it with the help of further equations. So let's see, as dy by dx is equal to 3 by 2 into x root, the length of curve is given by s, which is normally this one, and which is from 0 to 2 or 0 to 2, and that would be 1 plus 9 over 4 into x into dx, and s is equal to 2 by 3, and that is 4 by 9, and 4 by 9, and that is 1 plus 9 over 4 by x, that is 3 over 2, and that is 2 into 0, and that we can find by 8 by 27, and that is 1 plus 9 over 4 of x, 3 over 2, and that is 2 to 0, and we can have 8 by 27, which would be equal to 11 by 2 over 3 over 2 minus 1 is solution. Okay, so what we're going to do now, we're going to find the third application, which is the third application about surface area. Now we're going to have that one in our mind and find the surface area of a cone formed by rotating about x-axis, and the line which is y is equal to 2x between x is equal to 0 and x is equal to b. So s is equal to a into b 2 pi of y, which is equal to 1 plus dy over dx and x squared into d of x. So this is how you're going to solve it out. This one, we have our front of us, which is x, and this is y, this is a, and this is how you're going to resolve it out. For this one, this is this, and this is this, and this one has already been this, so this one will be d of x, this would be a over here, and dx is here, v is here. You can have like this, and you can have this one as well, and this one is b. F of x is equal to a into x, and v, we have this one which is in front of us, and now this is the surface area S. So let's see how we can able to actually explain this one with the help of the equations which is in front of us, this one. And when we're going to put out the values, the surface area would be how 0 to h 2 pi and 2 of x, and that would be 1 plus d over dx, 2x, and that would be whole square into dfx. And when you have 0 to h, 4 pi of x, 1 plus 2 square 1 by 2 into dx, and that would be 0 to h, 4 into 5 pi x into d of x, and that is 2 5 pi of x square, and that is from h0 to h. You can put it like 5 under root pi h square minus 0, so that would be 2 into 5 pi h square. And this is how you're going to explain it, and this would be the surface area. Okay, so this is how you will be able to actually explain this short bit of the concept. And now I'm going to talking about the fourth application, which is all about the volume of revolution, and that is also important. Volume of revolution. Find the volume of a cone enclosed by the surface formed by rotating about x-axis. The line y is equal to 2x between x is equal to 0 and x is equal to h. So how are we going to say it? That is the question. Find the volume of a cone enclosed by a surface formed by rotating about x-axis. The line y is equal to x between x is equal to 0 and x is equal to h. Let's see we can find about the solution. And the solution would be that v is equal to volume of a cone or a surface normally is represented a into b, which is pi y square over dx, and this is equal to 0 to h pi 2x square into dx, and this is 0. And probably the ink has been finished, so we're going to use it, and that is, let's see if I'm able to actually get the sort of and that would be 0 to h, and that would be 4 pi x square into d of x, that would be 4 over 3, and pi x cube, that is h to 0, and that is also 4 over 3 pi into h cube minus 0, so that would be 4 over 3 pi of h cube. That is the volume, and that is the volume of a cone, is the solution. Okay, so this is how you're going to end up with this formula, using up this formula, and you can have the volume of a cone as well, or volume of the revolution normally in terms of a cone. So this small bit of the exercise may help you to find some of the practical applications of what you can say the practical applications of integration. And we have solved out some of the examples related to the integration in plane polar coordinates, and we have solved out a bit of the theorem as well, and also we have discussed integral inequalities with the help of an example. I hope that is enough to actually grab the basic concepts of the integration, applications, inequalities, talking about the plane. And you can also go visit our previous video, and you can have your comments as well as far as the integration of the problems is concerned. So I have actually discussed with the next coming videos, we're going to definitely discuss some other topics which are essential to understanding the core applications, the core theory and applications of mathematical engineering. So with these remarks, I'm going to wind up my video, and if you see any sort of the contribution or any sort of the mistakes, please point it out. And if you want to have any problem to be resolved, do point out that put that problem in the comment section. We'll try to solve it out in a collaborative effort, so that we can meet the viewers and the requirements of the public as well. So with these remarks, I'm going to actually end up my video, and hoping to see you with the continuation of the same concept in the same channel. Till the next video, take care and have a nice day.